check. All right, so what we're going to do today is finish up our nomenclature that we started when we left off class on Friday. And we left off sort of talking about branches and branches of substituents of simple alkanes, and what I hope to accomplish today is to finish out that alkane section and then to cover some other functional groups. So, to start, if we look at 4 carbon compounds, and 5 and 6, we can also talk about if you take the same number of carbons in a molecule, same formula, you can have branches and shorter chains, as you can see here. And having these sorts of branches creates some interesting common names like isopentane and neopentane. But what it also does is it allows us to understand that if these branches, these complicated branches, were in fact part of a larger substituent on a larger chain, then we can see how these sorts of branches can create some interesting challenges for naming. So here we go. So here are the common names, and you can memorize these for the MCAT exam or the GRE if you want to, but for the large part, we're not going to use them very much because I'd rather teach you how to solve complex branch naming using the same sorts of skill sets that you already know how to use in naming substituents and in long carbon chains for simple alkanes. So here's an example. If we were to ask you to name this compound, the first thing you would do is you would identify the longest continuous carbon chain. In this case, there are 2 routes that we can take, but here's a simple one. And then we would say, okay, this is a hexane, and that there is a substituent or a branch on it. And if we were to circle the longest continuous carbon chain in the branch, we would say, hey, this is 2 carbons, so this is an ethyl branch. And again, using simple numbering systems, we would number 1, 2, 3, 4, 5, 6 in this direction, or we could number it in the reverse direction. And you can see that the 3 is a lower number than the 4, so this is now a 3-ethyl. And if you put the whole thing together, this would be 3-ethyl hexane. So very good. Now, let's see what happens if we put a branch on a branch. So if we put a branch on a branch, let's do this. There you go. So we have the longest continuous carbon chain, just like before, in this case. And again, this is now 7 carbons, so this is a heptane. But now we have this branch that also has a branch on it. So we can use the same sort of mechanics that we did before. Let's find the longest continuous carbon chain in the branch. And so if we do that, we can go in that direction and see 2 carbons. So this is an ethyl branch, but the ethyl group has a branch on its own, and in this case it's a methyl group. And so from a numbering perspective, we would say that this is an ethyl branch, but that there is a methyl group on it. So this is a methyl-ethyl branch, and because we know that that methyl group is on the first carbon of the branch, it's a 1-methyl-ethyl branch. And we put that whole thing in parentheses, and then the number on the root compound goes in front of that. So 1, 2, 3, 4, or 1, 2, 3, 4. It's the same way. So this would be a 4-1-methyl-ethyl heptane. All right? So I hope that's clear. Let's do another example, just for fun. Okay, so how about this one? Now, this is me being a little bit tricky. If we start counting numbers, 1, 2, 3, 4, 5, 6, 7, if we go down, 8, 9, 10, 11, 12, 13, and as you can see, this is the longest continuous carbon chain. Okay, so now we have a 13 carbon root compound, so this is tridecane. And now we go and look for the longest continuous carbon chain in the branch. So starting here, come out this way, and I can see that there are 4 carbons here. So this is a butyl branch. And again, numbering from where the branch connects to the root, 1, 2. This would be a 1,2 dimethyl butyl branch. It is found on 1, 2, 3, 4, 5, on carbon 7. So this would be 7, 1,2 dimethyl butyl tridecane. Okay? So I hope that's clear. There are a couple of examples I can give you, and so one of them might be this one. So one of the clever things we can do, and one thing I should tell you, is that if you have more than one of the same complex branch, instead of using the prefix di or tri or tetra, we use the terms bis, B-I-S. So in this case, 3, 4, this would be 6, 7 bis 1 methyl propyl, 3, 4 dimethyl 1-decane. And here's another example where the nomenclature committee just got into a fight and it makes for no sense. But remember from your regular nomenclature that if you have more than one simple branch, use di, tri, and tetra, and the di, tri, and tetra do not enter into the alphabetization of the name. So whatever, if you have two methyls, dimethyl still will come after ethyl. However, if you have complex branches and you use bis or tris or tetrakis, then in fact you have those prefixes do enter into the alphabetization of the name. So in this case the bis comes before the dimethyl. Hope that's clear, and we will finish up some nomenclature in a couple weeks. Hope this was helpful to you.